So after seeing this method, I decided to explore it for myself, and I ended up with something called the ice skate method. You'll see in a second. And this is for 2-digit times 2-digit multiplication. I am going to be off screen for most of this video, but if you hear any noises, that's my partner Ellie here. So the reason I called this the ice skate method is I designed this template and it looks like an ice skate. First, I'm going to write my two factors, 33 and 26. So the first thing he does in the video, and first thing I'm going to do, is multiply the ones place. So 3 times 6 equals 18. Now we do the tens place. 3 times 2 equals 6. For this method, I'm going to get in the habit of putting 0 in front of my single digit products. You'll see why as I go through some more examples. Next thing we're going to do is we're going to cross multiply. So we do 6 times 3, which gives me 18. 2 times 3 gives me 6. Now I'm going to actually add those two numbers together. So 18 plus 6 equals 24. And now I'm going to bring my 24 down. My last step is to add up my numbers, and I'll end up with 858. So 33 times 26 equals 858. Let's try another one. Remember, we're going to start in the ones. So 3 times 1 equals 3. Remember what I said previously, that whenever I get a single digit product, I'm going to put 0 in front of it. Next, we do 7 times 8 equals 56. Next, we cross multiply. 7 times 1 equals 7. 8 times 3 equals 24. 7 plus 24 equals 31. We bring that answer down. You may notice that when I bring 31 down, I leave a box blank. I'm going to explain that in a little bit. Now we just add the numbers through, and we'll end up with 5,913. This will also work with a really basic two-digit problem, 10 times 10. All right, we're going to start with the ones place. 0 times 0 equals 0. So I'm going to fill both boxes with zeros. Tens place, 1 times 1 equals 1. So I put that 0 in front of the 1. Cross multiply, 0 times 1 equals 0. 1 times 0 equals 0. 0 plus 0 equals 0. Bring that 0 down. And then we just add them through and end up with our final answer of 100. Obviously, I'm not advocating to use this method for 10 times 10, but I did want to illustrate that this method will work on the simplest two-digit problem. Let's go ahead and try another one here. 85 times 16. Let's start in the ones place. 5 times 6 equals 30. I drew that red outline to indicate that when you multiply the ones place, you're always going to use those first two boxes. So even if your answer ends up being a single digit product, you always have to fill in both boxes, and you can use 0 as your placeholder. Next, we multiply the tens place. 8 times 1 equals 8. Same thing here. Those second two boxes are reserved for the tens place. So even though I have a single digit product, I fill in both boxes. I put 0 as my placeholder. So I just want to take a step back real quick and explain the why behind this. So 5 ones times 6 ones will give me 30. So it makes sense that I would write 3 in my tens place, 0 in my ones place. So 8 tens times 1 tens is the same as 80 times 10. So 80 times 10 is 800. So it makes sense to put 8 in the hundreds place. Now, technically, you don't need to put that 0 in the thousands place, but I do want to just remain consistent of always having the rule of writing my answers as two-digit answers. Now we cross multiply. 8 times 6 equals 48. 1 times 5 equals 5. 48 plus 5 equals 53. I bring that 53 down. And then I add through to get my final answer of 1,360. All right, here's our last example, 21 times 36. Starting in the ones place, 1 times 6 equals 6. So again, I write my answer as 0, 6. Now we multiply the tens place. 2 times 3 equals 6. Again, get in the habit of writing single-digit products with two numbers, so I write 0, 6. Now we cross multiply. 2 times 6 equals 12. 3 times 1 equals 3. 12 plus 3 equals 15, and I bring that 15 down. Now, why do we leave that blank space when we bring 15 down? Let's backtrack and think about it. So let's go back to when we cross multiplied. So we start by doing 6 ones times 2 tens. So that would be the same as 6 times 20, which actually gives me 120. So when we do 3 times 1, it's 3 tens times 1, 1, or 30 times 1. So when we see 12 and 3 at the top, we actually aren't adding 12 plus 3. We're adding 12 tens plus 3 tens. So 12 tens plus 3 tens equals 15 tens. 15 tens is the same as 150. Therefore, we have to leave that blank space to show that we're representing 15 tens, not 15 ones. Our final step, we add the numbers through. We end up with 756. Sorry for the longer video. I had fun exploring this method, and I definitely wanted to give a lot of examples and explain the why behind why it works.